Picture a massive, heavy pendulum reaching the absolute silent peak of its grand, sweeping swing. For a fraction of a second, the entire universe appears to hold its breath, suspended entirely in a state of weightless, perfect stillness. Yet, beneath this comforting illusion of calm, our planet is actually hurtling through the pitch-black void at its absolute fastest and most terrifying orbital speed. If we were to look closer at the history of our turning world, we would find a legacy of awe written in stone and shadow. Ancient minds stood in the freezing dark, watching the horizon with bated breath as they waited for the sun to finally stand still. They built colossal megalithic clocks and meticulously carved mountain temples just to capture this exact, fleeting moment of cosmic surrender. Imagine the relief they felt when the celestial pendulum finally began its slow, inevitable return toward the warmth of the summer light. The physical world always recedes into the quiet, heavy commitment of the winter freeze, trusting that the orbital mechanics of the void will bring the morning back. It is a long dance of deep time, repeating in a rhythm that outlasts empires and countless fading generations. Surprisingly, this profound astronomical reality is not a puzzle you need to solve or reach for tonight. As your heavy head rests against the soft surface of your pillow, the relentless, silent spinning of the rock beneath your feet becomes nothing more than a gentle, rocking cradle. You're safe in this quiet room, sheltered completely from the cosmic winds and the vast, freezing expanse of the starry night. This cosmic structure of infinite light and deepest shadow is a grand, sweeping story written entirely for your peaceful rest. These wonders are yours to inherit as you sleep, carrying you effortlessly and securely through the longest night of the turning year. Notice the slow stretching of twilight shadows across a quiet, snow-dusted field. Notice the slow stretching of twilight shadows across a quiet, snow-dusted field. The fading light seems to pause, clinging to the frozen earth as if reluctant to surrender to the advancing night. This visual stillness mirrors a profound astronomical reality captured perfectly by the ancient minds who first tracked the sky. The word solstice itself descends from the Latin solstitium, a beautiful combination of sol, meaning sun, and sistere, meaning to stand still. For 6 months, the sun has been tracing an ever-changing arc across the horizon, creeping steadily northward or southward with each passing dawn. Yet, on this exact day, that relentless daily march finally comes to an abrupt and silent halt. If we were to look closer at the horizon day after day, we would see this turning point with our own eyes. The sun reaches its absolute highest or lowest declination in the sky, appearing to freeze in its celestial tracks for a few days before reversing its journey. This momentary pause is not an illusion, but the apex of a planetary pendulum swinging through the void, serving as the breathtaking climax of our orbit, and a singular breath caught in the throat of the cosmos before the seasons turn once more. Picture the fierce, unyielding heat of the June sun bearing down on the vast expanses of the northern hemisphere. While a snow-dusted field might define the winter experience for many, the summer solstice tells a story of direct, blinding illumination. Far above the equator, an invisible geographical line waits all year for this exact astronomical encounter. During the June solstice, the sun's rays strike the Tropic of Cancer directly at a perfect 90-degree angle. This invisible boundary, located at roughly 23.5 degrees north latitude, becomes the only place on Earth where a straight pole will cast absolutely no shadow at solar noon. The unfiltered energy of the star pours straight down through the atmosphere, concentrating its immense power onto the land and ocean below. This geometric perfection is a fleeting alignment, a fleeting kiss between the sun and the northern latitudes. As the Earth continues its relentless journey through space, the angle of the light will inevitably begin to soften and slant once more. Yet, for this singular moment, the Tropic of Cancer becomes the absolute centre of the solar target, basking in the most intense and direct light our planet can possibly receive. Deep within the Arctic Circle, the concept of a setting sun completely dissolves into a surreal golden haze. As the June solstice approaches, the familiar rhythm of day and night fractures, replaced by an endless sweeping arc of daylight. The snow-dusted fields of the far north are never allowed to fall into shadow, trapped in a continuous glowing twilight. The summer solstice brings the disorienting phenomenon of the midnight sun, where the day stretches into a full 24 hours of unbroken illumination. Because the top of the Earth is leaning as far toward the sun as physically possible, the planet's rotation simply cannot carry these high latitudes into the dark. Instead of dipping below the horizon, the sun merely skirts along the jagged edges of the landscape, casting long, strange shadows that slowly rotate in a massive circle. Conversely, when the Earth's orbit swings to the opposite extreme, the polar regions are swallowed by a beautiful, haunting darkness. The winter solstice plunges the poles into the deep blue twilight of the polar night, severing them entirely from the sun's warming gaze. It is a time when the snow-dusted fields reflect only the cold, distant glitter of starlight and the ethereal dancing ribbons of the aurora borealis. As the hemisphere tilts radically away from the solar system's heart, the sun fails to breach the horizon for days, weeks, or even months, depending on the latitude. The landscape is locked in a frozen, breathless stasis, painted in endless shades of indigo, violet, and charcoal. This is not merely a long night, but a fundamental alteration of the environment, where the absence of light defines the very shape of existence. Surprisingly, the atmosphere itself responds to this massive shadow, creating a dense, heavy chill that settles over the ice sheets. The polar night is a stark reminder of our planet's reliance on its star, a visual representation of deep space encroaching upon the atmosphere. It stands as the absolute antithesis of the midnight sun, a quiet, freezing meditation at the bottom of the world. Step outside on the crisp, freezing afternoon of the winter solstice and simply observe the ground beneath your feet. The pale light filters through the barren trees, casting stretched, distorted silhouettes across the snow-dusted field. This is not an optical trick of the cold air, but a direct consequence of the planet's severe tilt away from its light source. This orbital geometry ensures that your noon shadow is the absolute longest it will be all year on the day of the winter solstice. Because the sun traces its lowest possible arc across the southern sky, its light strikes the ground at a highly oblique grazing angle. Every object, from the tallest skyscraper to a solitary human figure, is forced to cast a dark, elongated twin that points directly toward the north. If we were to measure these shadows daily, we would see them slowly creeping outward since the height of summer, reaching their maximum stretch precisely on this day. It is a tangible, earthly measurement of a cosmic event, allowing anyone to verify the solstice with nothing more than their own outline. These exaggerated shadows serve as dark, quiet sundials, silently announcing the exact turning point of the solar year. Suspended high above the Earth, the stark division between light and dark reveals the true geometry of the solstice. This dividing boundary, known as the terminator line, sweeps continuously across the spinning globe, dragging dawn and dusk in its wake. Most of the year we imagine this line cutting straight down the middle of the planet, but the solstices warp this perception entirely. Surprisingly, the terminator line perfectly intersects the north and south poles only during an equinox, lying at its maximum possible slant during a solstice. On the winter solstice, this shadow line cuts drastically across the Arctic and Antarctic circles, visibly demonstrating the severe 23.5-degree tilt of the Earth's axis. From the vantage point of space, the planet appears lopsided, with one hemisphere aggressively hogging the sunlight, while the other cowers in the shadow. This tilted terminator is what physically creates the wildly disproportionate lengths of day and night we experience on the ground. It is the mathematical boundary condition of our seasons, a moving curtain of twilight that dictates the distribution of solar energy across the continents. Watching this slanted line creep across a map is to witness the very mechanism of the solstice laid bare. As the bitter cold settles over the snow-dusted field, the evening sky seems to hold on to its colours far longer than usual. The transition from day to night is not a sudden dropping of a curtain, but a slow, agonising bleed of bruised purples and deep oranges. The darkness hesitates, allowing the fragile waning light to paint the clouds for hours. Twilight lingers longest around the solstices, because the sun sets at an incredibly shallow glancing angle to the horizon. Instead of plunging vertically into the dark, the sun slides horizontally along the edge of the world, keeping its light refracting through the upper atmosphere for an extended period. This shallow trajectory means it takes significantly more time for the solar disk to sink a full 18 degrees below the horizon, the point where true astronomical night finally begins. This drawn-out dusk creates an extended period of liminal light, a magical, quiet phase where the world is neither fully illuminated nor completely dark. It offers a prolonged window of civil twilight, where the landscape is bathed in a soft, directionless glow that softens the harsh edges of the winter freeze. The solstice thereby gifts us not just the shortest day, but the most beautifully prolonged goodbye to the sun. This cosmic structure of light and shadow, of midnight suns and prolonged twilights, is not a product of our distance from the star. Many assume the freezing winter occurs because the Earth has drifted further away, but the truth is far more structural. The grand architecture of the seasons relies entirely on a permanent, unseen angle, locked deep within the planet's core. Earth maintains a strict 23.5-degree axial tilt as it orbits, which is the sole, uncompromising architect of these extreme solar turning points. Like a gyroscope spinning slightly off-centre, the planet holds this precise lean as it makes its massive elliptical journey around the sun. It is this fixed posture that forces each hemisphere to alternately bow toward and lean away from the solar furnace over the course of 12 months. Without this severe tilt, the concept of a solstice would simply not exist in our reality. The sun would rise and set at the exact same time every single day, casting the exact same shadows across the snow-dusted fields year after year. Our dynamic, violently changing seasons are entirely dependent on this beautiful, unbalanced flaw in our planetary posture, driving the endless cycle of life and dormant cold. Picture the sweltering, humid air of the equatorial tropics, a place often associated with relentless, punishing heat and permanent summer. It is easy to assume that the sun is always directly overhead at the centre of the world, blasting the equator with maximum intensity on the longest days of the year. Yet, the geometry of the solstice reveals a counterintuitive truth about how light is distributed across the planet's middle. If we were to look closer at the equator, we would find that the sun is actually never directly overhead on a solstice. When the northern hemisphere celebrates its summer solstice, the sun has migrated 23.5 degrees north to the Tropic of Cancer, leaving the equator behind. Consequently, an observer standing perfectly on the equatorial line during the June solstice will actually see the midday sun leaning significantly toward the northern horizon. This means that during the most extreme peaks of the solar year, the equator is experiencing a slight reduction in direct overhead sunlight. The true zenith of the sun only crosses the equator during the equinoxes, passing through on its way to the northern or southern extremes. The solstice, therefore, is the moment when the sun has strayed the absolute furthest from the middle of the world. A solitary figure stands in a snow-dusted field in the dead of winter, while precisely half a world away, someone else sweats under a blazing summer sky. Though their sensory experiences are wildly opposite, they are both participating in the exact same astronomical milestone. The solstice is not a creeping, localized event that travels across the globe like a weather front or a midnight countdown. The exact moment of the solstice happens for everyone on Earth at the exact same instant, regardless of local time zones or geographical location. It is a singular, universal coordinate in space, marking the exact microsecond when the Earth's tilted axis aligns perfectly with the incoming solar radiation. Whether your clocks read 3 AM or 4 PM, the planet reaches that definitive apex in its orbit simultaneously for all its inhabitants. This instantaneous reality unites the freezing darkness of the polar night with the blinding glare of the tropic sun. It reminds us that despite the vast differences in climate, daylight, and shifting shadows, we're all passengers on the same tilted, spinning sphere. The solstice is a fleeting planetary heartbeat, a shared fraction of a second where the entire world turns together in the dark. As the entire world turns together in the dark, humanity has long sought to capture that fleeting planetary heartbeat in stone. Feel the texture of rough, sun-warmed limestone glowing golden in the first light of dawn, a tactile bridge stretching across the millennia. Thousands of years ago, Neolithic builders perfectly aligned the entrance of the Newgrange tomb in Ireland to catch the exact trajectory of the winter solstice sunrise. This monumental mound of earth and quartz was engineered with a narrow, upward-sloping passage leading to a cruciform chamber deep within the dark interior. For most of the year, this inner sanctum remained swallowed by absolute impenetrable pitch black, isolated from the turning sky. Yet, on the morning surrounding the absolute lowest point of the solar year, a miraculous transformation occurs within the heavy earth. As the sun crests the horizon, a brilliant shaft of light pierces through a specifically designed roof box above the main entrance. This golden beam crawls slowly up the stone passageway, ultimately washing over the intricately carved basin at the very back of the tomb. It is a stunning triumph of prehistoric engineering, literally bringing the dying sun into the realm of the ancestors to ignite the promise of a new year. Far across the Irish Sea, another colossal endeavour sought to frame the opposite extreme of the solar journey. The massive, towering sarsen stones of the world's most famous megalithic circle were dragged across the landscape to create a precise astronomical viewing window. Here, the heel stone stands as a solitary sentinel outside the main monument, waiting silently for the apex of the summer season. When viewed from the exact centre of the ancient circle, this rough-hewn pillar aligns perfectly with the rising sun of the longest day. As dawn breaks, the glowing orb appears to balance momentarily upon the tip of the heel stone, casting a long, straight shadow directly into the heart of the complex. This intentional geometry transformed a chaotic, wild landscape into a highly tuned instrument for tracking celestial mechanics. The builders understood that this specific solar turning point dictated the rhythms of their agricultural survival, demanding a permanent marker. By capturing the sunrise in this precise configuration, they anchored the sweeping, untouchable movements of the cosmos to the heavy, immovable Earth. This site remains a profound testament to an era when observing the sky was indistinguishable from religious devotion and survival. Shift your awareness across the ocean to the dense, humid jungles of the Yucatan Peninsula, where limestone takes on a fiercely geometric shape. Sunlight creeping down the meticulously angled steps of El Castillo Pyramid creates a breathtaking optical illusion during these extreme orbital shifts. The Mayan architects designed this towering structure to serve as a colossal stone calendar, deeply integrated with the cycles of the heavens. As the late afternoon sun strikes the northwestern corner of the pyramid, it casts a series of 7 undulating triangular shadows against the western balustrade. These creeping shapes seamlessly connect with a massive carved stone reptile head resting at the absolute base of the staircase. To the gathered crowds below, it creates the terrifying and awe-inspiring illusion of a massive feathered serpent slithering down from the sky to touch the earth. This magnificent display of light and shadow is perfectly calibrated to the solstices and equinoxes, an ephemeral sculpture painted only by the sun. It demonstrates a mastery of mathematics, architecture and astronomy, fused together to manipulate sunlight into a divine message. Notice how your own breathing slows, settling into a calm rhythm as you contemplate the sheer ingenuity required to build such an extraordinary clock. Deep within the searing heat of the Egyptian desert, an even older civilization was binding their supreme deities to the mechanics of the solstice. The vast, sprawling complex of the Karnak temple features an architectural axis specifically orientated to the midwinter dawn. Here, the pharaohs designed a massive corridor of stone columns and towering pylons to channel the light of the most important day of the year. As the winter solstice sun clears the horizon, its weak, pale rays are funneled directly through the monumental eastern gate. This focused beam travels the entire length of the grand axis, piercing through the heavy shadows of the hypostyle hall. Ultimately, the light reaches the absolute deepest and most sacred part of the temple, illuminating the sanctuary of the supreme god Amun. This fleeting illumination was not merely a neat architectural trick, but a vital ritual meant to recharge the divine power of the Creator. By physically catching the sun at its lowest, weakest point, the temple structure was believed to help resurrect the light for the coming year. It is a stunning example of capturing the vast, untouchable geometry of the solar system within a confined, human-made space. High above the clouds in the jagged peaks of the Andes, the Inca Empire carved their astronomical devotion directly into the living bedrock of the mountains. The Intihuatana stone at Machu Picchu is an intricately sculpted granite outcrop, serving as both a sundial and a highly sacred altar. Its very name translates beautifully from the Quechua language to the hitching post of the sun. Inca astronomers precisely shaped the angles and planes of this monolithic carving to align with the sun's most extreme points of declination. During the December solstice, the sun rises to an angle that causes the main pillar of the Intihuatana to cast almost absolutely no shadow at all. For a civilization that worshipped the solar deity Inti, this shadowless moment was the pinnacle of their religious calendar. The priests believed this was the precise moment they could physically tie the sun to the earth, preventing it from continuing its journey and disappearing forever. By creating a stone that perfectly mirrored the sun's peak alignment, they felt they could control the celestial mechanics that governed their crops. The Intihuatana stands as a desperate, beautiful attempt to anchor the heavy heavens to the high-altitude stone. Surprisingly, complex solar tracking did not always require massive, labour-intensive pyramids or sprawling temple complexes to achieve breathtaking precision. In the harsh, arid canyons of the American Southwest, Native American astronomers of the Chaco culture utilized the natural environment to build a delicate trap for the light. High atop Fajada Butte, 3 massive, naturally eroded stone slabs lean against a cliff face, shielding a hidden rock carving from the glare of the day. Behind these heavy stone curtains, a meticulously pecked spiral petroglyph waits in the shadows for a specific cosmic alignment. As the summer solstice sun reaches its midday peak, a sliver of light slips through the narrow gaps between the massive rock slabs. This precise dagger of light creeps slowly downward, perfectly bisecting the center of the carved spiral in a silent, glowing display of astronomical mastery. This ethereal marker tracks not only the longest day of the year, but also the subtle 18-year lunar standstill cycle with astonishing accuracy. The Chacoans transformed a random geological collapse into a highly sophisticated observatory, leaving no heavy footprints, only the brilliant manipulation of shadow. Allow your shoulders to drop and your muscles to relax as you picture this silent, glowing dagger slicing through the ancient darkness. Journey to an island resting quietly in the center of the Mediterranean Sea, where some of the world's oldest freestanding structures rise from the scrubland. Visitors to the Mnazdra temples in Malta encounter a remarkably sophisticated spatial arrangement built by a mysterious, long-lost culture. These ancient engineers constructed massive clover-shaped limestone apses with an undeniable obsessive focus on the cyclical journey of our local star. The entire complex is oriented so that the main portal acts as a strict, unforgiving frame for the rising sun. During the vast majority of the year, the dawnlight simply illuminates the outer courtyard or strikes the heavy, unadorned walls of the inner chambers. However, the exact turning points of the solstices trigger a dramatic and entirely intentional shift in this subterranean lighting scheme. On these specific mornings, the sun shines directly through the main entrance, bypassing all obstacles to land perfectly on the edge of a decorated central altar. The builders utilised enormous megalithic blocks to essentially create a stone camera obscura, projecting the celestial turning point deep into their most sacred space. This precise illumination suggests that tracking the extremes of the year was central to their earliest communal rituals and survival. This architectural precision extends far beyond massive megaliths, finding subtle expression in the coastal fortresses built along the edges of the Caribbean Sea. The Tulum ruins in Mexico sit precariously on a jagged cliffside, their white stone structures contrasting sharply against the crashing turquoise water. Within this walled city, the relatively small Temple of the Frescoes hides a brilliant secret locked within its heavy stone-carved walls. High on the facade of this ancient building, a seemingly insignificant narrow window pierces the thick limestone barrier. For 363 days of the year, this dark slit offers nothing but a sliver of the ocean breeze to the interior room. Yet the entire building was mathematically rotated and settled onto the bedrock to accommodate one specific, fleeting beam of morning light. As the winter solstice sun breaks over the ocean horizon, its light threads the needle of this small window perfectly. The intense beam shoots across the dark room to illuminate the opposite wall, acting as an unmistakable alarm clock for the turning of the seasons. It is a quiet, understated miracle of engineering, capturing the vast orbital mechanics of the planet through a hole no larger than a human hand. Hidden deep within the scorching rose-red canyons of the Middle East, an entire city was carved directly into the towering sandstone cliffs. High in the treacherous mountains of Petra, the Nabateans applied their extraordinary engineering skills to map the movements of the sky. Their most monumental facade, known as the monastery, features an expansive open-air plaza that functions as a massive stage for the dying light of the year. Unlike monuments that chase the dawn, this sacred site was specifically aligned to capture the dramatic, fiery exit of the winter solstice setting sun. As the brief afternoon fades, the plunging shadows of the surrounding canyon walls swallow the plaza in encroaching darkness. However, a solitary gap in the distant mountain range allows one final, highly concentrated beam of light to strike the facade. This brilliant spotlight falls perfectly upon the sacred altar, carved into the back wall of the monastery's massive inner chamber. It creates a stunning halo effect, illuminating the Holy of Holies just as the rest of the world plunges into the longest night. Feel the gentle weight of your body pressing into your seat, grounded in the present, while imagining this ancient crimson light fading into the desert dusk. Long before stones were stacked in the deserts or carved into the mountains, the very first maps of the sky were drawn with simple decaying wood. Surprisingly, the oldest known solar observatory is the Goseck Circle in Germany, a Neolithic structure mapped entirely to the extremes of the solar year. Constructed an astonishing 7,000 years ago, it predates the pyramids and the great stone circles by millennia. This ancient monument consisted of massive concentric ditches and tightly packed wooden palisades, featuring specific narrow gates breaking the circular perimeter. These gates were not designed for defence, but were meticulously placed to align with the rising and setting of the sun on the winter solstice. The early farming communities who built it needed an infallible method to track the progression of the year, ensuring their survival through the freezing months. Standing in the centre of this vast earthen clock, a Neolithic observer would watch the sun perfectly frame itself within the wooden timber gates on the shortest day. Though the wood has long since rotted away, the dark stains left in the soil reveal the staggering astronomical intelligence of our earliest ancestors. It proves that the desire to measure the light, to understand our place in the spinning void, is one of the oldest and most fundamental human instincts. While our most fundamental human instincts drove us to understand our place in the spinning void with earthen clocks, a much vaster, fluid canvas silently records these orbital shifts. Listen to the rhythmic, surging breath of the rising swell crashing against a rocky shoreline, an immense body of water inhaling deeply under the pull of the cosmos. During the solstices, the gravitational forces of our local star and our natural satellite occasionally reach a point of profound, undeniable alignment. Solstitial tides, frequently referred to as king tides, manifest when the sun and moon reach their extreme declination points simultaneously. As the Earth leans to its maximum tilt, the combined gravitational drag pulls the global ocean surface into its most exaggerated, sweeping bulges of the entire year. This creates a spectacular marine phenomenon, where low tides drain local estuaries to their muddy floors, and high tides relentlessly pound against coastal sea walls. This dramatic shifting of mass is a powerful reminder that the ocean is not a static basin, but a flexible skin clinging to a rocky core. The tidal extremes offer a visceral, ground-level translation of planetary geometry, allowing us to physically witness the sun's gravitational anchor at its most severe angle. The crushing weight of the waves roaring onto the shore is the true, deafening sound of the solstice in motion. Counterintuitively, the longest day of the year does not instantly translate to the warmest waters for those seeking a midsummer swim. Despite the summer solstice delivering the absolute maximum payload of direct solar radiation, the oceans reach their peak temperatures weeks or even months later. This massive delay is caused by thermal inertia, an inherent physical property of water that requires immense amounts of energy to alter its baseline temperature. As the high sun relentlessly bakes the surface, the vast, churning volumes of the sea slowly absorb and distribute this heat downward into the pelagic zones. The water acts as a planetary heat sink, soaking up the solstice energy like a colossal sponge before finally radiating that warmth back into the air late in the season. Consequently, the true stifling heat of the oceanic summer arrives long after the sun has already begun its inevitable retreat toward the equator. This thermal lag creates an atmospheric buffer that dictates global weather patterns, smoothing out the harsh extremes of the shifting sky. Without this watery delay, the continents would fry instantly under the June peak and freeze the moment the sun began to lower. Take a slow, deep breath and feel the steady rhythm of your own pulse, a quiet echo of the deep, delayed currents churning across the globe. Deep within the frigid waters of the high northern latitudes, a similar delayed reaction dictates the dramatic transformation of the frozen seascape. The sprawling caps of sea ice do not suddenly vanish the moment the endless daylight of the summer turning point arrives. Instead, these massive floating glaciers reach their absolute minimum extent several months after the continuous sunlight has initiated the vast seasonal melt. It takes an agonizingly long duration of relentless round-the-clock solar bombardment to break down the highly reflective, hardened surface of the pack ice. The intense energy from the solstice sun must first warm the surrounding dark waters, which then begin to aggressively erode the frozen boundaries from the bottom up. Thus, the visual climax of the Great Melt is a delayed geological echo, occurring only when the days have already grown significantly shorter and cooler. Watching the ice recede is to witness a timeline that is fundamentally out of sync with the sky above. The ocean remembers the heat of the longest day, slowly executing a structural collapse long after the astronomical trigger has passed. It is a slow, majestic, and melancholic withdrawal, a delayed reaction to a fleeting celestial alignment. If we were to map the invisible highways of the sea, we would witness the global conveyor belt making subtle adjustments to its massive flow. Major ocean currents experience distinct shifts in their thermal transport efficiency as the zone of maximum solar heating moves to its extreme northern or southern limits. When the solstice sun concentrates its intense thermal energy on a specific hemisphere, the resulting temperature gradients physically alter the density of the surface waters. This microscopic change in water density slightly modifies the speed and trajectory of vast warm currents winding through the deep blue expanse. the entire planetary plumbing system softly recalibrates, redirecting tropical heat toward the polar sinks in a slightly altered pattern to compensate for the extreme angle of the incoming light. It is a majestic and entirely silent response, ensuring the planet maintains its delicate thermodynamic equilibrium across thousands of miles of open water. These shifting currents carry immense implications for the marine ecosystems that rely on their steady, predictable flow of nutrients. The solstice thereby acts as a subtle conductor, slightly altering the tempo and direction of the ocean's most vital, life-sustaining rivers. This dynamic shifting proves that the stillness of the solstice is an illusion, masking a world in constant fluid compensation. Plunge miles beneath the churning waves, descending past the sunlit zones into the crushing, lightless void of the bathypelagic depths. Here, the concept of a seasonal turning point is stretched into an almost unrecognizable, ghostly whisper of thermal exchange. Deep-sea temperature lags so significantly behind the sunlit surface that the sweeping abyssal plains barely register the orbital shifts happening far above. While the solstice dictates explosive bursts of life and heat in the shallows, the bottom of the ocean remains locked in a near-freezing eternal stasis. Any microscopic fraction of solstice warmth that manages to filter down through the immense water column takes centuries to complete its journey via slow vertical mixing. Down in this perpetual darkness, the fiery drama of the changing sky is reduced to nothing more than a faint delayed statistical anomaly. The deepest trenches of the ocean are effectively divorced from the mechanics of the solar year, existing in a permanent crushing midnight. The creatures here do not look to the sun for the changing of the seasons, but rely entirely on the slow drift of organic snow falling from the chaotic world above. Notice the comfortable stillness of your legs resting in your chair, mimicking the undisturbed, peaceful isolation of those silent, untouchable benthic plains. Surprisingly, the most spectacular biological responses to the sun's turning point occur not on land, but across the vibrant, bustling architecture of tropical reefs. Certain species of coral time their massive synchronized spawning events to specific lunar cycles that occur shortly after the peak of the summer solstice. These tiny stationary polyps possess an uncanny ability to read the subtle shifts in water temperature and the duration of twilight that define this exact time of year. By waiting for the water to warm slightly post-solstice and aligning with a specific phase of the moon, entire reef ecosystems coordinate to release billions of gametes simultaneously. This underwater blizzard of life relies entirely on the precise geometry of the solar year, maximizing the chances of fertilization in the vast open water. The astronomical turning point acts as the ultimate biological trigger, setting the clock for one of the most magnificent reproductive displays on the planet. This coordinated explosion of colour and movement ensures the survival of the reef, turning the dark ocean into a swirling galaxy of new life. It demonstrates an ancient genetic memory tied directly to the tilt of the Earth, a beautiful intersection of orbital mechanics and cellular biology. The solstice does not merely cast long shadows, it literally commands the reef to bloom. Drift back toward the icy, nutrient-rich waters near the poles, where the arrival of continuous daylight sparks an explosion visible from low orbit. Phytoplankton blooms in these frigid regions erupt into massive swirling galaxies of vibrant green just as the sun delivers its uninterrupted payload of light. For months, these microscopic organisms have lingered in the dark, dormant and waiting for the ice to recede and the solar angle to shift. When the solstice finally bathes the high latitudes in unbroken radiation, the rate of aquatic photosynthesis skyrockets exponentially across hundreds of miles of water. These sudden, massive blooms form the fundamental base of the entire marine food web, drawing massive pods of baleen whales and flocks of seabirds to the seasonal feast. The extreme orbital tilt of the planet is therefore entirely responsible for turning a barren, freezing ocean into the most biologically productive water on Earth. From space, these blooms look like magnificent, impressionistic paintings swirling in the dark currents, a visual testament to the power of the sun. The solstice sun acts as a key, unlocking a frozen vault of nutrients and sparking a frantic, temporary rush of consumption and growth. It is a stunning, fast-paced contrast to the slow, grinding nature of the ice, fueled entirely by the geometry of light. Picture the sheer, rocky cliffs of the Californian coastline, where the height of summer paradoxically ushers in a thick, chilling blanket of grey mist. Coastal fog banks in these specific regions are ironically thickened by the intense summer solstice sun pulling freezing water up from the deep ocean floor. As the high sun violently heats the inland valleys, rising hot air creates a massive vacuum that pulls strong, persistent winds across the surface of the nearby sea. These relentless winds push the warm surface waters away from the shore, causing icy, deep ocean currents to forcefully upwell and take their place. When the warm, moisture-laden Pacific air inevitably collides with this newly surfaced freezing water, it instantly condenses into a heavy, sprawling fog. Thus, the brightest, hottest day of the astronomical year directly engineers the freezing, blinding gloom that swallows the shoreline. This localized cooling effect provides vital moisture to ancient redwood forests, sustaining entire ecosystems with the ocean's ghostly breath. It is a brilliant, counterintuitive loop of atmospheric physics, where extreme solar radiation effectively manufactures its own shadowy shield. Let your eyes softly defocus for a moment, embracing a comfortable blur that mirrors the rolling, peaceful haze of that coastal fog creeping inland. This intricate atmospheric dance extends far out into the open sea, dictating the very rhythm and power of the waves that eventually strike the continents. If we were to measure wave propagation closely, we would find that solstice wind patterns subtly alter the kinetic energy of long-distance swells traversing the Pacific. The extreme shift of the intertropical convergence zone during the sun's apex fundamentally reorganizes the dominant trade winds and high-altitude jet streams. These altered wind corridors generate massive rolling swells in the deep ocean, pushing energy across thousands of miles of featureless water with renewed directional focus. Surfers on distant shores often reap the delayed benefits of these seasonal storms, riding waves whose immense power was birthed by the atmospheric pressure extremes of the solstice. The turning of the Earth is mathematically translated into aquatic momentum, carrying the memory of the shifting sky straight into the crashing surf. Each wave that breaks upon the sand holds a fraction of the sun's seasonal journey, a kinetic echo of a distant swirling storm. The ocean acts as a massive transmission medium, conveying the energy of the solstice across the globe through the simple, repetitive lifting and falling of the tide. It is an endless global pulse, driven by the hot breath of the sun upon the water. Finally, consider the rare moments when the intricate gears of our celestial clockwork lock into a position of absolute unyielding alignment. The absolute highest astronomical tides of an entire decade happen only when a solstice coincides perfectly with the climax of a major lunar standstill. The moon's orbit is slightly tilted relative to the Earth's equator, meaning its own highest and lowest points in the sky operate on a complex cyclical wobble. When the sun reaches its maximum solstice declination at the exact same time the moon reaches the absolute peak of its own cycle, their gravitational vectors fuse completely. This incredibly rare cosmic synergy pulls the ocean to its absolute physical limits, flooding coastal marshes and raising sea levels to astonishing temporary heights. It is the ultimate expression of the ocean's quiet response, a towering, fluid monument to the invisible, inescapable forces that bind our spinning world. These monumental tides wash away the familiar boundaries between land and sea, redrawing the map for a few fleeting hours. They serve as a powerful, humbling reminder that the Earth is constantly being manipulated by the massive, silent bodies floating in the dark. In these moments, the water does not just respond to the solstice, it reaches up, desperate to touch the sky. Deep within the tissues of every living creature, an ancient timepiece ticks in perfect synchronization with the rhythmic tilt of the sky, mirroring the way the oceans reach up, desperate to touch the light. Mammals, ranging from the nomadic caribou of the high tundra to the smallest forest mouse, possess a sophisticated circannual clock that interprets the extreme photoperiod of the solstice as a direct biological command. As the solar arc reaches its highest or lowest point in the celestial sphere, specific sets of genes within the suprachiasmatic nucleus are activated or suppressed in a carefully choreographed sequence. This internal mechanism does not require the observation of a calendar or the ticking of a watch. It simply reads the relative length of the day and night as a powerful chemical signal. By tracking the exact moment the sun appears to stand still, the mammalian body knows exactly when to initiate shifts in energy storage, hormonal balance, and basal metabolic rate. Every individual cell acts as a silent witness to the solar cycle, ensuring that the organism is never caught off guard by the inevitable arrival of the changing seasons. This deep-seated rhythm serves as a constant internal echo of the planet's massive journey through the void. Surprisingly, the vastness of the universe provides a meticulously timed early warning system for those who must flee the coming freeze long before the air turns cold. While the late summer atmosphere may still feel thick and humid with the residual heat of a high sun, migratory birds begin to sense a subtle, undeniable change the moment the summer solstice passes. The sudden, microscopic drop in daylight hours acts as a primary chemical cue that overrides the immediate signals of their warm, lush environment. This decreasing photoperiod is detected by specialized sensors in the avian brain, triggering the production of hormones that induce a state of migratory restlessness known as zugunrua. Compelled by this internal shift, these travelers begin an obsessive period of feeding to accumulate massive, calorie-dense reserves of subcutaneous fat to power their journey. Their bodies effectively become living batteries, charged by the realization that the sun is no longer climbing toward its peak. This physiological transition happens weeks before the first true frost, guided entirely by the descending arc of the solstice sun as it begins its retreat toward the equator. If we were to look closer at the vibrant, rustling canopy of an ancient woodland, we would find that the trees themselves are masters of celestial navigation. Deciduous forests do not wait for the arrival of biting northern winds or the first heavy dusting of frost to begin their dramatic, colourful transformation into autumnal shades. Instead, these towering rooted organisms react strictly to the changing angle of the sun as it shifts in the weeks immediately following the summer solstice. Within each leaf, specialised light-sensitive pigments known as phytochromes measure the duration of darkness with a degree of accuracy that rivals modern scientific instrumentation. As the nights begin to lengthen, the tree initiates the construction of a physical abscission layer at the base of every leaf stem, effectively sealing the foliage off. This is a vital defensive maneuver designed to protect the tree's internal moisture and nutrient reserves before the ground freezes solid. The spectacular display of carotenoids and anthocyanins is merely a visual symptom of the tree's profound response to the astronomical retreat of the solstice light. The silence of the earth and the deep hollows of ancient fallen logs provide a sanctuary where a profound stillness settles over the hibernating world. As the winter solstice arrives, the extreme lengthening of the night signals a time for animals to initiate the deepest and most perilous phases of their seasonal torpor. This is not a simple state of sleep, but a radical physiological shutdown where the heartbeat slows to a mere flutter and body temperatures plummet toward the freezing point. To prevent their blood from freezing, many of these creatures produce specialized cryoprotectant chemicals that act as a natural antifreeze within their veins. Notice the weight of your own body as you rest in this moment, perhaps feeling a faint shadow of that same heavy restorative stillness. This deep torpor is a masterpiece of energy conservation that turns the harshest astronomical point of the year into a period of safe, quiet retreat. By aligning their lowest metabolic state with the absolute nadir of the sun, these creatures endure the frozen void through the power of absolute quiet. Arctic landscapes, where the solstice creates a surreal world of blue twilight and silver snow, force their inhabitants to undergo physical transformations that border on the mythical. Reindeer possess a unique ocular adaptation that allows them to thrive in the radically shifting light conditions of the high northern latitudes. During the brilliant high-energy daylight of the summer solstice, their eyes appear as shimmering golden orbs, specifically optimized to handle the intense glare. However, as the planet tilts and the winter solstice plunges the tundra into months of dim, indigo-tinted twilight, their eyes undergo a remarkable structural change. The tapetum lucidum behind the retina shifts the spacing of its collagen fibers, causing the eyes to turn a deep, luminous, and electric blue. This transformation significantly increases the sensitivity of their vision, allowing them to capture the faintest glimmers of light reflecting off the ice. It is a stunning biological mirror of the solstice itself, a literal change in the way the world is perceived, dictated by the massive tilt of the Earth's axis. This cosmic structure of light and shadow also governs the intricate, time-sensitive blooming cycles of the global floral world. Plant photoperiodism is a sophisticated biological clock that ensures certain species, such as the vibrant poinsettia, will only bloom when the nights reach a specific critical length. These plants do not measure the ambient temperature or the moisture of the soil to determine their reproductive timing. They count the hours of darkness with absolute precision. If a stray artificial light were to break the long solstitial night for even a short duration, the plant might fail to produce its iconic bracts. The winter solstice provides the exact threshold of deep shadow required to trigger the hormonal shift from simple leaf growth to complex flower production. It is a delicate photosynthetic dance with the dark, where the plant waits for the longest night of the year to announce its presence. In this way, the garden becomes a living, blooming map of the solar year, responding directly to the silent movement of the stars. If we were to track the delicate, orange-winged travelers crossing the North American continent, we would witness a masterpiece of instinctive solar navigation. Monarch butterflies possess a highly specialized internal sun compass that allows them to calibrate their flight path across thousands of miles of varied terrain. As they begin their arduous journey toward the high-altitude forests of Mexico, they rely on the descending angle of the sun to maintain direction. Even as the sun moves across the sky during the day, their biological clocks allow them to adjust their heading to compensate for the drift. The shifting declination of the star as it approaches the winter solstice provides the vital, continuous data they need to stay on their ancestral course. Without this celestial guidance, these fragile insects would be utterly lost in the vastness of the open landscape. Their massive migration is a living testament to the influence of the solstice, a journey spanning generations and guided by a single distant light. Beneath the soil, the universe leaves a long-term thermal memory that waits for a specific astronomical signal to release its long-hidden secrets. The emergence timing of periodical cicadas is partially governed by the cumulative solar energy absorbed by the crust of the Earth leading up to the solstice peak. These insects spend the vast majority of their decades-long lives in subterranean tunnels, feeding silently on the fluids of tree roots in the dark. They possess no eyes to see the rising sun, yet they know exactly which year and which specific day to emerge by the millions in a synchronized awakening. The ground acts as a massive thermal battery, storing the heat of successive summer solstices until a specific critical threshold is finally reached. Notice the ease in your breathing, perhaps imagining the patient, dark weight of those millions of creatures resting just below your position. Once the soil temperature hits a precise level following the solar peak, the massive, noisy emergence begins, echoing the warming of the planet's heavy heart. Within the shadowy, quiet depths of a dense forest, the architecture of light undergoes a radical transformation as the sun reaches its highest celestial point. Light penetration in deep forest canopies changes drastically during the summer solstice, creating a brief and vital window for the life that clings to the mossy forest floor. During the height of the summer season, the sun is at its most vertical position, allowing sharp rays to pierce through accidental gaps in the leafy roof. These fleeting sunflecks are the primary source of energy for understory plants that otherwise live in a state of perpetual dim shadow and low light. This brief period of high-angle illumination provides a necessary burst of direct photosynthesis that sustains these ground-dwelling species for the remainder of the year. The solstice effectively opens a temporary golden door in the sky, delivering a precise payload of energy to the quietest corners of the woods. It is a realignment that proves that even in the deepest shade, the movement of the sun dictates the very possibility of growth. Finally, consider the snowshoe hare, a creature whose very physical appearance is a direct, visible reflection of the sky's changing photoperiod. This animal undergoes a complete and laborious molting process twice a year, shedding its brown summer coat for a thick white winter camouflage that blends into the frozen landscape. Surprisingly, this transformation is triggered entirely by changing light levels and the shifting duration of the day, regardless of whether snow has actually fallen on the ground. This rigid biological schedule can lead to a dangerous phenomenon known as camouflage mismatch, where a white hare stands out sharply against a dark, snowless earth. The animal's internal biology is locked into an ancient, uncompromising schedule dictated by the astronomical calendar, showing no flexibility for local weather patterns. It is a stark reminder that the fundamental laws of the solstice are hard-coded into the very DNA of the wild. The hare's white fur is a beautiful commitment to the promise of the coming winter, a visible echo of the fading light. As the physical world recedes into the quiet commitment of the winter freeze, the sky above begins to broadcast a visible echo of the fading light. Feel the crisp, static-filled chill of a dry winter air mass pressing down from the sky, a heavy weight that signals a fundamental reorganization of the planet's invisible machinery. The global atmospheric circulation shifts its entire mechanism toward the poles as the summer solstice pushes the intertropical convergence zone to its maximum latitude. This massive migration of heat and moisture acts as the primary engine for the world's weather, dragging the belt of tropical storms far from the equator. As the sun stands still at its northern or southern limit, the Hadley cells expand and contract in a grand planetary respiration that dictates where deserts form and where forests drink. It is a total rearrangement of the sky's architecture, driven by the uncompromising geometry of our orbital tilt. If we were to look closer at the satellite data, we would see the very breadth of the Earth shifting its focus to compensate for the extreme solar imbalance. The solstice is not just a date on a calendar, but a physical trigger that force restarts the global wind belts, ensuring that energy is redistributed across the spinning globe. This atmospheric tide is the silent, high-altitude partner to the surging oceans, carrying the signature of the solstice through the thin, cold air. High above the temperate lands, the rivers of air known as jet streams begin to pulse with a violent and unpredictable grace as the seasons reach their peak. During the winter solstice, the temperature gradient between the sun-drenched equator and the shadow-shrouded pole sharpens to a razor's edge. This thermal contrast acts like a tightening spring, causing the jet stream to meander more aggressively and throw massive serpentine loops across the continents. These atmospheric waves, known to scientists as Rossby waves, pull freezing polar air masses deep into regions that usually bask in milder climates. A single wobble in this high-altitude current can transport a piece of the Arctic heart thousands of miles south, flash freezing the landscape in a matter of hours. The sky is essentially a fluid battlefield where the energy of the summer hemisphere constantly attempts to breach the defences of the winter dark. Surprisingly, the universe provides this chaotic movement as a form of planetary cooling, preventing the poles from becoming infinitely cold and the tropics from boiling over. The solstice is the moment of maximum tension in this system, the point where the jet stream must work hardest to reconcile the light and the dark. It is a high-speed, high-altitude drama that dictates the survival of everything resting beneath the clouds. Deep within the stratosphere, Far above the reach of common storms, a powerful and ghostly sentinel known as the polar vortex achieves its tightest, most stable rotation during the absolute darkness of the winter solstice. Without a single ray of sunlight to warm the upper air, a massive swirling cyclone of near-vacuum frigidity becomes locked over the geographic pole. This atmospheric fortress acts as a containment vessel, trapping the most extreme cold on Earth within a high-speed ring of wind. This spinning shield of ice-cold air remains remarkably stable as long as the sun remains below the horizon, creating a self-contained world of blue twilight and starlight. The vortex is a masterpiece of fluid dynamics, born from total shadow, a literal whirlpool in the sky that defines the structural peak of the winter season. It is only when the solstice passes and the first light returns to the high atmosphere that this crystalline structure begins to wobble and eventually shatter. Notice the steady, rhythmic expansion of your chest as you breathe, a small and grounded counterpoint to the massive swirling rotation of the vortex miles above your head. This high-altitude cyclone is the guardian of the winter, a silent and spinning testament to the power of the Earth's shadow. It serves as a reminder that the most profound changes in our environment often happen in the places we can never reach. Surprisingly, the warmest days of the year on the ground in the Northern Hemisphere coincide with the most extreme and paradoxical deep freeze in the upper sky. High in the mesosphere, roughly 50 miles above the surface, the summer solstice creates the perfect frozen conditions for shimmering electric blue noctilucent clouds to form. As the lower atmosphere expands with the intense heat of the high sun, it pushes the mesosphere higher, causing it to cool to temperatures below -200 degrees Fahrenheit. In this surreal and airless heights, water vapor begins to freeze onto tiny particles of meteor dust drifting in from deep space. These night-shining clouds are so high that they remain illuminated by the sun long after the world below has fallen into total darkness. They appear as gossamer ribbons of neon blue, rippling like waves on an invisible ocean against the blackness of the void. This phenomenon is a stunning visual contradiction, where the peak of summer heat on the Earth's surface manufactures a piece of the coldest winter in the sky. The solstice sun acts as a cosmic backlight, revealing the hidden structures of our atmosphere that exist on the very edge of space. These clouds are the highest on the planet, a fragile and beautiful echo of the sun's maximum reach. Auroral activity often presents unique atmospheric geometries during a solstice due to the severe tilt of the Earth's magnetic field relative to the solar wind. While the northern and southern lights dance across the sky throughout the year, the angle of the planet's magnetic shield changes its interaction with the sun's charged particles at these orbital extremes. This can lead to a phenomenon where the auroral ovals are skewed or shifted, creating rare shapes and patterns visible only during these weeks. The Earth's magnetosphere acts like a giant windsock in the solar stream, and the solstice represents the moment when that sock is at its most tilted orientation. This geometry can create cracks in the magnetic field, allowing solar energy to pour into the upper atmosphere with unexpected intensity. The resulting light show is a visual map of our planet's specific orientation in the solar system, a glowing broadcast of our place in the void. If we were to look closer at these shimmering curtains of green and violet, we would see the magnetic field lines warping and snapping under the pressure of the solstice alignment. It is a celestial dialogue between our star and our planet, written in the language of plasma and light. The solstice provides the perfect angle for this cosmic energy to paint its most intricate and distorted masterpieces across the polar sky. Tropospheric wind patterns reverse entirely in regions affected by monsoons, driven by the intense solstice heating of massive continental land masses. As the summer sun stands still over the northern latitudes, the vast plains of Asia and Africa become colossal thermal engines, heating the air until it rises with immense vacuum-like force. This rising air creates a massive low-pressure zone that sucks moisture-laden winds from the distant cooler oceans. This seasonal shift is a direct result of the extreme thermal contrast generated by the solstice, triggering the heavy rains that sustain billions of human lives and countless ecosystems. When the winter solstice arrives and the land finally cools, the process reverses with equal authority, sending dry, cold air rushing back toward the sea. The atmosphere essentially flips its entire directional flow twice a year, guided by the movement of the solar zenith. This grand reversal is a powerful reminder that the solstice is a global event with tangible, life-altering consequences for the soil and the sea. The winds are the messengers of the sun, carrying the energy of the solstice across thousands of miles to transform the landscape. It is a rhythmic planetary scale inhalation and exhalation that defines the boundaries of the habitable world. Notice the stillness in your hands as you contemplate the invisible forces of the sky, grounding your awareness in the solid world while the air above remains in constant flux. Sudden stratospheric warming events are most likely to disrupt global weather patterns in the weeks following the winter solstice. These events occur when large-scale atmospheric waves from the lower sky break into the stratosphere, causing temperatures to spike by dozens of degrees in just a few days. This localized heat wave in the upper sky can effectively shatter the polar vortex, sending its fragments of freezing air spinning southward toward the waiting cities. It is a chaotic and delayed response to the thermal stresses built up during the longest nights of the year. When the stratosphere warms, the jet stream often buckles, leading to the most severe and lingering winter storms recorded in modern history. These events prove that the atmosphere has a memory, a way of storing the energy imbalances of the solstice and releasing them in sudden, violent bursts. The sky is never truly at rest, even when the sun appears to stand still. This high-altitude turbulence is the atmospheric price we pay for the dramatic tilt that gives us our seasons, a final shivering echo of the winter peak. The albedo effect reaches its absolute peak during the winter solstice, as expansive snow cover reflects the already weak solar radiation back into space. As the planet tilts away from the sun, the white crystalline surfaces of the high latitudes act as a planetary mirror of staggering proportions. Instead of absorbing the meagre heat of the low sun, the snow sends up to 90% of that energy straight back into the cold darkness of the void. This creates a self-reinforcing cooling loop, where the presence of snow ensures the air remains cold enough to prevent that very snow from melting. The winter solstice provides the perfect geometry for this massive, icy reflection to dominate the Earth's energy budget, effectively locking the hemisphere in a deep freeze. The light that does reach the ground is treated as an unwanted guest, bounced away before it can do the work of warming the soil. This massive rejection of solar energy is why the landscape feels so uniquely bright and sharp on a clear winter day. The Earth is essentially shielding itself from the sun, using the remnants of past storms to maintain its frozen integrity. It is a stunning display of planetary physics, where the colour of the ground dictates the temperature of the sky. This vast reflection of energy, combined with the slow cooling of the land and oceans, guarantees that the coldest days of winter arrive long after the shortest day has passed. Just as the oceans take weeks to warm after the summer peak, the atmosphere experiences a significant thermal lag as it sheds its residual summer heat. Even though the days begin to lengthen almost immediately after the winter solstice, the Earth continues to lose more energy to space than it receives from the weak returning sun. This imbalance persists for weeks, pushing the true seasonal low into the depths of January or February, long after the astronomical turning point. The solstice is merely the beginning of the journey into the deepest part of the frozen season, the moment the brakes are applied to a cooling world. We live in the shadow of the past, feeling the thermal debt of the long nights even as the light begins its slow, triumphant return. This delay is a vital part of the planet's rhythm, providing a buffer that prevents the climate from shifting too violently or too quickly. It allows the natural world to transition slowly into and out of its dormant states, guided by the steady, heavy hand of thermal inertia. The cold that bites at your skin in midwinter is the true, lingering echo of the solstice night. If we were to release a high-altitude weather balloon on the exact day of the solstice, its trajectory would map the most extreme seasonal pressure gradients of the year. The sensors would record the violent contrast between the dense, heavy air of the winter pole and the lighter, rising air of the summer hemisphere. This pressure difference is the primary driver of the global wind system, creating a planetary-scale engine that strives to reach equilibrium across the void. As the balloon rises through the cooling layers of the troposphere and into the thin air of the stratosphere, it would experience the sheer force of the solstice in the form of high-altitude winds and radical temperature shifts. It would see the terminator line cutting a sharp, slanted path across the clouds, marking the boundary between the day and the long night. The balloon's journey is a final scientific measurement of the atmospheric echo produced by our planet's tilted path through the stars. Its drifting path serves as a signature of the solstice, a silent line drawn in the sky that connects the frozen ground to the edge of space. In those thin, cold heights, the reality of our planetary movement becomes undeniable, a physical sensation of falling through the universe. We're all carried along in this grand atmospheric wake, moving together through the cycles of light and air. Moving together through the cycles of light and air, we find that the human mind has always been desperate to pin these shifting currents down to the precision of ink and geometry. Over 2,000 years ago, a scholar named Eratosthenes stood in the Great Library of Alexandria, contemplating the relationship between the sun and the curve of the horizon. He had heard reports from the southern city of Syene, where on the summer solstice the sun shone directly down into a deep well, casting no shadow at all. Recognizing a singular opportunity to measure the entire world, Eratosthenes waited for that same day in Alexandria and measured the shadow cast by a vertical pillar at noon. This simple, sharp shadow provided the exact angle he needed to calculate the curvature of the Earth's surface between the two cities. By applying the principles of geometry to this solitary solstice shadow, he realized that the angle of the sun was exactly 1/50th of a circle. This brilliant deduction allowed him to calculate the entire circumference of our planet with a degree of accuracy that remains staggering to modern science. He successfully translated the fleeting position of the sun into a physical dimension of the Earth, effectively mapping the void through a single point of light. This was the moment where the abstract movements of the heavens were finally tethered to the tangible reality of the ground. Surprisingly, the universe leaves a long exposure signature of its movements that can be captured over the course of an entire solar year. If you were to photograph the sun from the exact same location and time every single day, the resulting composite would reveal a graceful, elongated figure 8 suspended in the sky. This hauntingly beautiful shape is known as an analemma, and it serves as a visual map of our planet's orbital eccentricities and its permanent axial lean. The analemma features the solstices as its absolute highest and lowest loops, marking the furthest points of the sun's annual journey across the celestial sphere. The top of the 8 represents the summer solstice, where the sun reaches its peak altitude and appears to linger before beginning its long descent once more. Conversely, the bottom loop marks the winter solstice, the absolute nadir of the sun's path where the days are shortest and the shadows reach their maximum stretch. This complex curve is dictated by the fact that Earth's orbit is an ellipse rather than a perfect circle, causing the sun to appear slightly ahead of or behind our clocks at different times of the year. The width of the loops illustrates the solar equation of time, a mathematical correction required to align human time with the sun's natural rhythm. It is a stunning, ghostly reminder that our path through the void is never a simple circle, but a swaying, delicate dance. This cosmic structure is mirrored in the sharp scratch of a brass caliper sliding across a weathered parchment map, a tactile pursuit of the sun's hidden borders. Antique astrolabes, often described as the mathematical jewels of the Middle Ages, were intricately engraved with circular lines representing the celestial equator and the two tropics. These fine markings allowed a mariner or scholar to determine the sun's maximum and minimum altitude for any given day of the year. By aligning the instrument with the horizon and the star's position, a user could solve complex astronomical problems without ever touching a pen to paper. Within these brass rings, the solstices were treated as the definitive boundaries of the habitable world, the points beyond which the sun would never stray. Navigators relied on these engraved solstice limits to calculate their latitude with remarkable accuracy, while tossing on the dark, unpredictable waves of the open ocean. Each astrolabe was a miniature universe held in the palm of a hand, a map of the solar journey cast in durable metal. The engraving served as a permanent reminder that even in the centre of the sea, the sky provided an infallible set of coordinates. These instruments turned the light of the solstice into a practical tool for exploration, bridging the gap between the stars and the deck of a ship. Deep within the tangled, humid jungles of Central America, the Mayan civilization developed a calendar system of such terrifying precision that it rivaled the calculations of contemporary European scholars. Their astronomers relied on highly sophisticated naked-eye observations of the horizon to track the solstice as it moved through the changing seasons. By carefully noting the exact point where the sun rose and set against the distant jagged mountains, they could predict the turning of the year with absolute certainty. This astronomical data was not merely academic, it was the lifeblood of their agricultural cycles, dictating the precise timing for burning the brush and planting the maize. The intricate interplay between their various calendar rounds ensured that every social and religious event was synchronized with the movements of the sky. They viewed the solstice as a critical pivot point in the cosmic order, a moment when the sun god reached his limit and began the necessary return journey. As you settle into the stillness of your own frame, feel the gentle rise of your chest, mirroring the ancient patience of those who watch the jungle sky. The Maya understood that human survival was inextricably linked to the geometry of the heavens, and they built their cities as stone mirrors of the stars. Their legacy is a reminder that even without the benefit of glass lenses, the human eye is a powerful instrument for deciphering the secrets of the sun. Across the vast, windswept plains of ancient China, the pursuit of solar precision led to the construction of massive, towering instruments made of cast bronze and stone. Chinese astronomers utilized enormous gnomons, some reaching over 40 feet in height, to record the exact length of the midday shadow throughout the year. These structures were essentially giant vertical scales, designed to capture the subtlest shifts in the sun's altitude with millimeter precision. During the winter solstice, the shadow would stretch to its absolute maximum length, creeping across long horizontal stone runways known as shadow templates. By marking the exact tip of this shadow at the precise moment of solar noon, the astronomers could determine the length of the solar year to within a few minutes. This data was vital for the emperor's calendar, which was considered a divine mandate and a source of political stability for the entire realm. This unwavering commitment to measurement allowed them to detect subtle irregularities in the Earth's rotation centuries before other cultures. They treated the solstice as a moment of supreme balance between the forces of nature, requiring the most accurate observations possible. The bronze gnomons stand as silent, metallic witnesses to a time when the length of a shadow was the most important measurement in the human world. To visualize the invisible mechanics of the heavens, Greek scholars constructed elaborate armillary spheres that functioned as three-dimensional maps of the cosmos. These skeletal models featured a series of nested metal rings, each representing a vital boundary in the celestial architecture. At the center sat a representation of the Earth, surrounded by circles defining the celestial equator, the meridian, and the tropics. A wide, slanted ring known as the ecliptic traced the annual path of the sun as it moved through the constellations of the zodiac. This model allowed students and philosophers to observe exactly where the ecliptic path of the solstice sun intersected the higher and lower limits of the celestial sphere. By rotating the rings, they could simulate the appearance of the sky for any latitude and any specific day of the solar year. The armillary sphere was a triumph of visualization, transforming abstract orbital mechanics into a tangible, rotating object of study. It reminded the viewer that the solstice was not a random occurrence, but a predictable intersection of two vast geometric planes. These spheres brought the infinite scale of the universe down to a size that could be understood by the human mind and felt by the human hand. During the flourishing of the Islamic Golden Age, the world's most advanced astronomers compiled extensive solar declination tables known as Zij. These scholars worked in magnificent observatories from Baghdad to Samarkand, refining the inherited knowledge of earlier civilizations with rigorous new observations. They understood that the angle of the sun was a critical variable for determining the exact times of daily prayer and the orientation towards sacred sites. Their tables recorded the sun's position for every day of the year, tracking the slow, daily shift of its declination with unprecedented mathematical rigor. Each entry in the Zij was a testament to the belief that understanding the heavens was a path to absolute truth and cosmic harmony. By accurately predicting the moment of the solstice, they could ensure that the lunar and solar cycles were reconciled with the needs of the faith. Their work laid the foundations for modern trigonometry and spherical astronomy, turning the movements of the solstice into a universal language of numbers. They saw the standing still of the sun as a moment of profound mathematical beauty, a fixed point in an ever-changing sky. These tables allowed the light of the solstice to be calculated and predicted across the vast reaches of the desert. Allow the tension to drain from your shoulders as you contemplate the slow, heavy drift of centuries, grounding yourself in the immediate present. Time itself is a slippery medium, and for over 1,000 years the Western world operated on a calendar that was slowly but surely falling out of sync with the stars. The Julian calendar was a revolutionary improvement for its time, but it contained a tiny, nearly invisible mathematical flaw. By overestimating the length of the solar year by roughly 11 minutes, the calendar caused the date of the solstice to drift backward through the months at a rate of about 1 day every century. To a single generation, this shift was imperceptible, but over the long arc of history, the astronomical reality began to diverge significantly from the written date. By the middle of the 16th century, the winter solstice was occurring 10 days earlier than the calendar claimed it should. This slow, relentless drift created a growing crisis for social and religious life, as the calculation of key holidays relied on the timing of the seasons. The people were living in a world where the physical seasons and the civil calendar were no longer in agreement, creating a profound sense of temporal vertigo. It proved that even the most powerful authority could not ignore the uncompromising laws of the solstice. This temporal crisis finally demanded a radical intervention from the highest levels of authority, leading to one of the most significant calendar reforms in human history. Pope Gregory XIII introduced the Gregorian calendar in 1582, guided by a team of mathematicians who sought to repair the damage of the Julian drift. Their primary objective was to realign the shifting solstice and equinox with the traditional liturgical dates that governed the year. To achieve this, the Pope issued a decree that simply excised 10 days from the calendar, ordering the world to jump from October 4th to October 15th overnight. This sudden leap across time effectively reset the solar clock, bringing the written date back into harmony with the physical position of the Earth in its orbit. By also adjusting the leap year rules to prevent future drift, they created a system that remains accurate to this day. It was a bold attempt to master time itself, ensuring that the solstices would remain anchored to their rightful places in the human story. Many people at the time were confused and even protested the loss of those 10 days, feeling that their lives had been unnaturally shortened. Yet this correction was necessary to ensure that the light of the solstice would once again match the date on the wall. If we were to trace the silent movement of a shadow across the face of a classical sundial, we would witness a hidden geometry carved by the sun itself. Sundial design principles dictate that the path traced by the tip of a shadow changes its shape throughout the seasons, following strict mathematical laws. On the days of the equinox, the shadow follows a perfectly straight line, a singular moment of linear balance in the turning year. However, as the solstice approaches, this line begins to curve and bend under the influence of the Earth's axial tilt. During the winter and summer solstices, the shadow lines form dramatic, sweeping hyperbolas that define the absolute limits of the sun's reach on the dial face. These elegant curves are the physical manifestations of a cone of light intersecting the flat plane of the sundial. This curvature serves as a permanent stone record of the planet's orientation in space, a silent broadcast of our 23.5-degree lean. To read a sundial is to observe the intersection of time and geometry, where the solstice is written in the language of the curve. These sweeping arcs are the fingerprints of the sun, left behind on the surface of our world to remind us of our place in the stars. Deep within the velvet darkness of geostationary orbit, satellites perched 36,000 kilometers above the equator maintain a precarious and rhythmic relationship with the Earth's massive shadow as they help us navigate our place in the stars. While these metallic sentinels frequently plunge into communication-blocking solar eclipses around the spring and autumn equinoxes, the solstices offer a period of unbroken, glorious illumination. The vast bulk of the planet fails to intersect the line of sight between the machine and its star, creating a celestial window of pure energy. During these extreme planetary tilts, the satellite's high-altitude path carries it far above or below the reach of the planet's conical shadow, allowing it to bypass the darkness of the Earth's bulk entirely. This ensures that their critical missions are never interrupted by the sudden onset of orbital night, leaving their massive solar arrays bathed in continuous, unrelenting sunlight for weeks at a time. The batteries remain topped at their maximum capacity, and the internal heaters operate with a steady, predictable efficiency that is impossible during the eclipse seasons. It is a season of maximum energy production and thermal stability, a celestial grace period where the footprints of our technological reach are never erased by the shadow of our homeworld. These sweeping arcs are the fingerprints of the sun, left behind on the surface of our world and mirrored in the constant golden glow of our highest machines as they watch the stars. The solstice provides the ultimate stability for the invisible networks that bind our global civilization together in the dark. This structure of constant light requires a delicate and relentless mechanical response from the machines we have cast into the void. Spacecraft engineers must remain ever vigilant, meticulously calculating the shifting geometry of the solar year to protect their fragile multi-billion-dollar payloads from the thermal hazards of the star. During an orbital solstice, the sun's position relative to the spacecraft reaches its most extreme northern or southern declination, creating an angle of incidence that challenges every standard operating procedure. To maintain peak efficiency and prevent the silicon cells from losing power as the geometry shifts, the massive wing-like solar panels must be tilted to aggressive, unorthodox angles. This mechanical adjustment is a silent, robotic dance performed in the absolute vacuum, ensuring the photons strike the collectors at the most productive and safe trajectory possible. The articulation of these metallic limbs is the only way to compensate for the planet's 23.5-degree lean, a physical manifestation of the solstice occurring in the silence of deep space. If we were to look closer at the telemetry streaming back to Earth, we would see the actuators straining to track a star that has wandered to the very edge of its expected celestial track. This constant realignment prevents the internal components from freezing or frying, maintaining a delicate homeostasis amidst the void. Each degree of rotation is a mathematical tribute to the solstice, a necessary pivot that keeps our electronic eyes open and alert. Surprisingly, the universe allows for a form of artificial stasis that enables us to monitor our changing world with unprecedented consistency and scientific detail. Earth observation satellites often utilize a specialized path known as a sun-synchronous orbit, a narrow and precise corridor designed to pass over any given location at the exact same local solar time. Achieving this level of temporal precision requires a total mastery of orbital mechanics that accounts for the planet's non-spherical shape and its annual solstitial shifts. By precisely calibrating their altitude and inclination around the specific extreme parameters of the solstice, these sentinels ensure they always view the surface with a perfectly consistent angle of lighting. This allows scientists to compare images taken months or even years apart without being deceived by the natural lengthening or shortening of shadows on the ground. The solstice serves as the ultimate benchmark for this calculation, the fixed extreme against which all other lighting angles are meticulously measured and verified. The metallic hum of the sensors above captures the Earth in a perpetual state of noon or twilight, depending on the specific mission requirements. This constant illumination is only possible because the orbit is designed to precess, or wobble, at exactly the same rate that the Earth moves around the Sun. It is a technological triumph that turns the predictable, seasonal movement of the planet into a steady, reliable gaze that never blinks. Floating within this high-speed environment, the International Space Station encounters a unique set of thermal challenges as the planet reaches its annual solar peak. During high beta-angle solstice periods, the station's orbit aligns so closely with the direction of the Sun that it experiences almost no time at all in the cooling shade of the Earth's shadow. This creates a situation where the exterior of the station is bombarded by solar radiation for the entirety of its 90-minute journey around the globe. To prevent the delicate internal life support systems and the human crew from overheating in this relentless glare, flight controllers on the ground must execute a series of complex maneuvers. The station's massive thermal radiators, which look like silver, accordion-like panels, are turned edge-on or angled away from the persistent solar rays to dump excess heat into the infinite cold sink of space. This prevents the station from becoming a solar oven, maintaining a habitable environment for the astronauts living on the edge of the world. Notice the steady, rhythmic expansion of your lungs, a grounded contrast to the silent, frantic cooling of a laboratory hurtling through the vacuum at 17,000 miles per hour. This thermal adjustment is a vital survival tactic, a technological response to a solar environment that has effectively become a relentless 24-hour furnace. Every radiator tilt is a silent acknowledgement of the solstice's power, a necessary shield against the star's maximum reach. If we were to examine the invisible, electrically charged layers of our atmosphere, we would see a world that is constantly being reshaped by the sun's seasonal journey. GPS receivers used in everything from modern smartphones to intercontinental aircraft must apply subtle, nearly invisible timing corrections to maintain their legendary level of accuracy. These corrections are necessitated by the ionosphere, a sprawling layer of plasma that reacts violently to the changing intensity of solar radiation across the shifting hemispheres. As the solstice shifts the sun's maximum energy focus across the globe, the ionosphere naturally thickens and thins in a predictable seasonal pulse that follows the solar zenith. This shifting density changes the speed at which satellite signals travel through the sky, potentially introducing errors of several meters if the software fails to compensate for the planetary tilt. The signals are slightly delayed by the extra electrons, requiring a mathematical correction that is synchronized with the astronomical calendar. Every receiver essentially carries a mathematical map of the solstice, anticipating the solar weather before the signals ever reach the ground. This ensures that the distance to the satellite is calculated down to the nanosecond, providing a stable coordinate system for a world in motion. It is a hidden, digital acknowledgement of the Earth's tilt, occurring millions of times every second in the palms of our hands to ensure our place in the stars is always known. This cosmic proximity causes the uppermost layers of the atmosphere to swell and expand as they are bombarded by a slightly higher intensity of solar energy and charged particles. During the winter solstice in the northern hemisphere, the Earth reaches perihelion, the point in its elliptical orbit where it is physically closest to the blazing heart of the Sun. This creates a counterintuitive situation where the atmospheric drag on satellites can actually fluctuate based on the orbital position rather than just the season. However, the specific geometry of the winter solstice means that this expansion is distributed differently than in the summer, occasionally leading to a slight and unexpected drop in satellite drag. Because the Sun is lower in the sky, the density of the air at specific orbital altitudes can thin out, allowing missions to maintain their altitude with slightly less fuel. This provides a momentary gift from the laws of orbital mechanics, easing the strain on the propellant tanks of aging satellites. It is a powerful reminder that even at the edge of the void, the Earth remains a dynamic, swelling entity that responds to the proximity of its star. The satellite feels the breath of the planet as it expands and contracts with the solstice, a tactile interaction between the machine and the atmosphere. This subtle drop in resistance is the silent physical signature of the winter perihelion, written in the decaying orbits of our metallic explorers. High-gain antennas located at the furthest corners of our planet are constantly engaged in a struggle to hear whispers from the furthest reaches of the solar system. Background thermal noise, which can drown out the faint signals from Voyager spacecraft or Mars rovers, reaches specific, predictable low points depending on the antenna's orientation away from the solstice sun. These massive dishes are so sensitive that even the radio frequency hum of our own star can act as a blinding wall of static. When the sun is at its maximum declination during the solstice, it occupies a position in the sky that allows certain ground stations to point their massive dishes toward the dark depths of the celestial poles. By looking as far away from the sun's radio-noisy neighbourhood as possible, these instruments achieve a state of crystalline clarity that is impossible at other times of the year. The coldness of the deep sky becomes a quiet backdrop, allowing the most distant human voices to be heard with perfect fidelity. Feel the ease in your hands as you imagine this silent metallic search for meaning in the dark, where the solstice effectively clears the airwaves for the stars. The orientation of the Earth acts as a natural shield, using the planet's own bulk to block the interference of the sun. In these moments of high-angle solstice, the connection between our world and the deep interior of the solar system is at its most serene and focused. Space weather forecasters monitor the sun with heightened scrutiny during the solstices, knowing that the planet's orientation can significantly amplify the effects of solar storms. The violent eruptions of the star, known as coronal mass ejections, pose a constant threat to our global power grids and the sprawling, fragile networks of communication satellites. During the solstices, these massive clouds of charged plasma strike the Earth's magnetosphere at a more oblique and precarious angle than they do during the equinoxes. This slanted geometry can lead to unpredictable and often more intense interactions as the solar wind attempts to breach the planet's magnetic defenses at their most tilted orientation. Forecasters must adjust their complex mathematical models to account for this oblique impact, which can funnel energy into the upper atmosphere in concentrated, potentially dangerous bursts. A storm that might be minor in March can become a major event in June or December, simply because of the way the Earth is leaning. The solstice acts as a celestial magnifying glass for solar activity, turning a standard eruption into a potentially disruptive event that reminds us of our fragility in the relentless solar stream. Our electronic infrastructure is tethered to the whims of a star, and the solstice is the moment when that tether is pulled the tightest. It is a time for vigilance as we watch the invisible tides of the sun wash against the magnetic shores of our world. If we were to look closer at the chemistry of the high atmosphere, we would find that our polar satellites are the only witnesses to a secret seasonal trauma. These polar orbiting sentinels provide a constant chilling record of the ozone layer's health as it fluctuates with the extreme and unforgiving rhythms of the solar year. Ozone thickness reaches its most dramatic and dangerous lows in the weeks immediately following the deep freeze of the winter solstice, particularly over the frozen reaches of the Antarctic. During the absolute darkness of the polar night, unique and complex chemical reactions occur within high-altitude ice clouds that have been untouched by a single ray of sunlight for months. When the first rays of the returning sun finally strike these clouds after the solstice, they trigger a rapid, explosive release of chlorine that aggressively destroys ozone molecules in a matter of days. This creates the infamous ozone hole, a seasonal depletion that is a direct consequence of the solstice-driven cold and the sudden return of light. Satellites capture this sudden, spreading depletion as a vivid, bruised purple patch on their digital sensors, a literal scar left by the winter's cold that remains until the light returns in full to heal the sky. It is a chemical echo of the longest night, a reminder that the solstice's influence is written in the very molecules that protect our world from the sun's harsher radiation. This measurement is a vital piece of the planetary puzzle, tracked with metallic precision from the edge of the void. From the silent metallic view of the void, the Earth's long magnetic tail changes its sweeping motion through the solar system based on the planet's extreme solstitial tilt. Extending millions of kilometers into the void behind our planet, the magnetotail is a vast invisible structure shaped by the relentless pressure and speed of the solar wind. This magnetic wake does not trail straight back like a simple ribbon, but instead undergoes a complex, rhythmic, sweeping motion as the planet wobbles through its annual orbit. As the Earth leans to its maximum solstice angle, the tail is forced to wag up and down across the orbital plane, tracing a wide and invisible arc through the thin interplanetary medium. This motion radically alters the way the planet traps and releases energy from the sun, influencing the frequency and intensity of geomagnetic storms that ripple across the entire globe. The tail becomes a dynamic, living extension of our world, responding to the tilt of the axis with every passing second. From this distant perspective, the Earth appears as a giant wobbling magnet, its invisible tail broadcasting the state of the solstice to the cold, distant outer planets. It is the final, grand signature of our orientation, a silent movement that defines our magnetic footprint in the deep expanse of the stars. The solstice is not just an event on the surface, it is a structural change that reaches out and touches the very edge of our planetary influence. Beyond the edge of our own planetary influence, the solar system reveals a world where structural change has reached its most chaotic and beautiful extreme. Uranus, the pale cyan ice giant, does not merely tilt, it rolls through the void like a massive ball on a cosmic track. Its rotational axis is inclined at a staggering 98 degrees, meaning the planet effectively orbits on its side relative to the Sun. This radical orientation creates the most extreme and prolonged solstice conditions found anywhere in our local neighbourhood. During this period, one pole is aimed directly at the Sun, remaining bathed in continuous, unblinking light for 21 Earth years. While one half of the world basks in this eternal solar glare, the other is plunged into a freezing, lightless abyss that lasts for over 2 decades. The transition between these seasons is a slow, agonizing process that completely reorganizes the chemistry of the planet's methane-rich atmosphere. Massive high-altitude storms erupt as the sunlight finally touches clouds that have been frozen in shadow for an entire generation. It is a world where the traditional concept of a day is lost, replaced by a solstitial cycle that defines the very architecture of the Uranus year. Picture the dusty reddish glow of a distant sun setting on a frozen Martian dune. This familiar sight masks a seasonal asymmetry that is far more dramatic than anything experienced on the greener shores of Earth. Because Mars travels along a highly elliptical path, its distance from the Sun fluctuates significantly, creating solstices of wildly varying intensity and duration. The southern summer solstice occurs when the red planet is at perihelion, its absolute closest approach to the solar furnace. This coincidence triggers a violent influx of energy, causing the southern hemisphere to experience summers that are significantly hotter and more turbulent than their northern counterparts. These soaring temperatures drive the rapid sublimation of the southern carbon dioxide ice cap, releasing a sudden surge of gas into the thin atmosphere. If we were to look closer at the global weather patterns during this time, we would witness the birth of planet-wide dust storms. These towering clouds of iron-rich sand can grow to shroud the entire world in a choking orange haze for months on end. The northern solstice, arriving when the planet is furthest from the Sun, is a much calmer and colder affair, highlighting the lopsided and unpredictable nature of the Martian year. This cosmic architecture of extreme seasons and violent shifts finds its absolute antithesis in the king of the planets. Jupiter, the massive gas giant wrapped in swirling bands of ammonia and sulfur, stands almost perfectly straight up in the dark. With an axial tilt of merely 3 degrees, the planet's rotational axis is nearly perpendicular to its orbital plane. Surprisingly, this means the giant has virtually no solstices at all, maintaining a state of perpetual unchanging equinox across its vast latitudes. The Sun remains at nearly the same height in the Jovian sky throughout its 12-year orbit, denying the planet the dramatic seasonal transitions found elsewhere. The Great Red Spot and the colourful jet streams do not shift their positions in response to a tilting sun. They are fueled primarily by the planet's own internal heat. Notice the weight of your body pressing into your seat, a gentle gravity that grounds you while you contemplate the stability of such a massive world. On Jupiter, the shadows at the poles never grow long or short, and the temperature at the equator remains at a constant freezing baseline. It is a world of eternal static weather, where the solstice is a forgotten concept in a sky that never bows. Elsewhere in the solar system, the presence of a solstice is marked by the most magnificent shadow in the known universe. Saturn, the ringed jewel of the outer planets, tilts at an angle similar to Earth's, ensuring a rhythmic and spectacular change in its lighting. During Saturn's solstice, its magnificent ring system is illuminated from a high angle, casting its widest and darkest shadow across the planet's gaseous surface. This shadow acts as a colossal striped curtain, cutting through the hazy atmosphere of the northern or southern hemisphere with clinical precision. The rings effectively block the sun's warmth, creating cold spots in the atmosphere that can trigger localized storms and shifts in wind speed. From a distance, the planet appears to be wearing its own shadow, a dark band that tracks the sun's height with every passing month. The rings themselves also undergo a visual transformation, appearing at their most expansive and brilliant when viewed from the direction of the sun. This is the peak of the Saturnian summer, a time when the rings reflect maximum light back into the void. It is a stunning interplay of light and geometry, where a planet's greatest feature becomes a tool for measuring its own seasonal journey through the stars. Deep within the furthest reaches of the gas giants, Neptune endures a winter solstice of terrifying and beautiful proportions. This deep blue world, buffeted by the fastest winds in the solar system, takes nearly 165 years to complete a single trip around the Sun. Consequently, its seasonal transitions are stretched out over timescales that dwarf the span of a human life. Neptune's winter solstice triggers deep atmospheric storms that rage in absolute frigid darkness for 40 Earth years. As the hemisphere tilts away from the weak, distant sun, the upper atmosphere loses its meagre heat source and begins to churn with immense kinetic energy. These storms appear as massive dark spots in the clouds, swirling vortices larger than our entire homeworld. The sheer duration of this dark season allows for chemical processes that are impossible in shorter cycles. Methane ice clouds form in the deep freeze, casting ghostly reflections in the dim starlight of the outer system. It is a world of cold, dark and relentless motion, where the solstice marks the beginning of a 40-year night that reshapes the very face of the planet. If we were to venture into the Kuiper Belt, we would encounter a world where the laws of the solstice have been completely rewritten by a chaotic history. Pluto, the frozen dwarf planet with a heart of nitrogen ice, undergoes solstice rhythms that are among the most erratic in the solar system. Because it has an extreme axial tilt of 120 degrees, the planet is technically upside down relative to its orbit. This radical lean plunges its nitrogen ice glaciers into shadow for over a century at a time, creating a deep freeze that turns the atmosphere into a solid layer of frost. When the sun finally returns after more than 100 years of darkness, the ice sublimates instantly, creating a temporary and thin atmosphere that eventually freezes back onto the surface. It is a violent and beautiful cycle of death and rebirth, driven by the most severe tilt imaginable. allow your muscles to soften and your breath to become shallow, mimicking the thin and fragile atmosphere of this distant, icy shore. Pluto's solstice is not a day, but a generational epoch that dictates the geological activity of its entire surface. The long shadows cast by its jagged mountains are monuments to a darkness that lasts longer than most human civilizations. This structure of seasonal transformation reaches a fluid and alien climax on Saturn's largest moon, Titan. Wrapped in a thick nitrogen-rich haze, Titan is the only other world in the solar system known to have stable liquids on its surface. The transition into a summer solstice on Titan drives massive methane rainstorms that flood its alien lakes and carve deep riverbeds into the frozen crust. The sun's warmth, though weak at such a distance, is enough to trigger a global hydrological cycle where methane takes the place of water. As the solstice sun heats the northern or southern polar regions, the liquid evaporates and forms towering, hydrocarbon clouds that eventually burst in torrential downpours. These storms can last for years, reshaping the coastline of the dark, oily seas of Ligaia and Kraken Mare. If we were to look closer at the surface, we would see the landscape changing in real time under the influence of the sun's tilt. The solstice is the engine of Titan's weather, the primary force that moves liquid across its vast orange plains. It is a familiar rhythm of rain and evaporation, played out in a world of sub-zero temperatures and chemical complexity. Surprisingly, the second planet from the Sun offers a solstice that is fundamentally inverted by its own rebellious nature. Venus experiences an upside-down solstice because the planet rotates backward on its axis, a phenomenon known as retrograde rotation. This means that if you could see through the thick acidic clouds, you would watch the sun rise in the west and set in the east. This backward spin, combined with an axial tilt of less than 3 degrees, effectively makes its north pole its south pole from a rotational perspective. While the thick greenhouse atmosphere keeps the temperature at a permanent, lead-melting baseline, the sun still traces a subtle path through the clouds. The solstice on Venus is a quiet, nearly invisible event, hidden beneath thousands of miles of crushing golden haze. Beneath the scorching glare of the sun's nearest neighbour, the very concept of a solstice begins to dissolve into a state of eternal, frozen stillness. Because Mercury has essentially zero axial tilt, its rotational axis is perfectly perpendicular to the plane of its orbit. This lack of a lean means the sun always sits exactly on the horizon at the planet's poles, never rising higher and never setting. This geometry creates deep craters at the poles that are in a state of eternal twilight, completely untouched by the concept of a solstice or seasonal change. These cold traps are among the coldest places in the solar system, despite being located on a planet that can melt zinc at its equator. Within these shadows, deposits of water ice have remained frozen for billions of years, protected by the planet's lack of a tilt. Notice the profound silence of this arrangement, a world where the sun never moves from its place in the sky. Without a solstice to stir the heat or change the shadows, these polar regions are the most stable environments in the solar system. Mercury is a planet of extremes that never meet, a place where the lack of a solstice is the most significant astronomical fact of all. Ultimately, our understanding of the solstice is the key that unlocks the mysteries of the thousands of alien worlds orbiting distant stars. Astronomers modelling exoplanets use the presence or absence of a solstice tilt to determine if an alien world might harbour stable, life-supporting climates. A planet with a moderate tilt, like Earth, is more likely to have a diverse range of habitable zones and seasonal rhythms that drive biological complexity. If we were to look closer at a world with no tilt, we might find a planet locked in a state of permanent stagnant weather that prevents the distribution of nutrients and heat. Conversely, a planet with a wild Uranian tilt might be too chaotic for life to ever take hold, in the face of decades-long nights and scorching days. The solstice is the primary variable that dictates the heartbeat of a planet, the pulse of its energy and its potential for life. As you rest in the quiet of this moment, realize that your own survival is a direct result of the specific, gentle tilt of the Earth's axis. The light of the solstice is a beacon that we look for across the light years, a signature of a world that is just balanced enough to be called home. We are searching for that 23.5-degree lean in the dark, hoping to find another world that turns together under a distant sun. As we turn together under that distant sun, our planet performs a slow and majestic dance that spans tens of thousands of years in the silent dark. The Earth is not a perfectly stable sphere spinning in the void, but a massive, slightly lopsided top that performs a rhythmic and nearly invisible wobble. This phenomenon, known as axial precession, ensures that the direction our North Pole points toward the stars is in a state of constant and perpetual flux. Today, we look to Polaris as our North Star during the quiet of the winter solstice, but 10,000 years ago the sky was anchored to a different beacon entirely. This grand cycle takes roughly 26,000 years to complete a single rotation, meaning the celestial maps of our ancestors were radically different from our own. It is a hauntingly slow movement that proves even the most permanent fixtures of our sky are merely passing through. Deep within the structural memory of the planet, the very angle of our planetary lean is in a state of constant, rhythmic and mysterious flux. The obliquity of the Earth, the specific degree to which our axis is tilted away from the vertical plane of the orbit, is not a fixed constant in the dark. Over a vast cycle of 41,000 years, this angle gently rocks back and forth between roughly 22 and 24 degrees. When this tilt is at its minimum, the differences between the seasons are softened, and the solstices are much less extreme than the ones we experience in our modern era. This means the winter nights are slightly less dark and the summer days are less intense, creating a more uniform climate across the globe. We are currently positioned in the middle of this long-term rocking motion, coasting between the extremes of the planet's deep time posture. This cosmic structure of movement is further complicated by the way our entire elliptical path rotates through the void, like a shifting plate on a table. Known to astronomers as apsidal precession, the long axis of the Earth's orbit slowly turns in space, causing the dates of our closest and furthest approaches to the star to migrate through the calendar. Eventually, after thousands of years of this slow rotation, the winter solstice will no longer coincide with our closest point to the sun, fundamentally altering the thermal intensity of our shortest days. This ensures that the specific relationship between planetary distance and axial tilt is never exactly the same from one millennium to the next. It is as if the Earth is travelling on a track that is itself slowly spinning, creating a complex and layered pattern of light and heat. This migration of the orbit is one of the many invisible hands that shape the long-term climate of our homeworld as we fall through the infinite stars. Surprisingly, the universe uses these overlapping cycles of wobble, tilt, and orbital rotation to dictate the very survival of life across the sprawling continents. When these various rhythms align in a specific and rare configuration, they can drastically cool the intensity of the summer solstice sun in the northern hemisphere. If the heat of the longest day is not strong enough to melt the previous winter's heavy accumulation of snow, the ice begins to build up year after year, eventually forming massive glaciers. These frozen giants begin to grind across the land with a slow, mile-high weight, advancing millimetre by millimetre over several millennia. Feel the slow, heavy weight of your own limbs as they rest against the earth, perhaps sensing a faint shadow of that same patient pressure of the advancing ice. This is the celestial mechanism that triggers the onset of planetary ice ages, proving that the geometry of light is the ultimate master of our world's temperature. If we were to look closer at the star maps of our prehistoric ancestors, we would find a sky that is almost unrecognizable to the eyes of a modern observer. Due to the slow and relentless drift of the zodiac caused by the planet's precession, ancient humans witnessed the solstice sunrise against a completely different backdrop of stars. The constellations that we associate with the beginning of winter or summer today did not occupy those same sacred positions for the people who first walked the earth. The sun rose in different houses of the zodiac, meaning the cultural and mythological significance of the solstice was tied to entirely different celestial patterns. Those who carved symbols into the walls of caves looked up at a winter solstice that was framed by stars we now see in different seasons entirely. This drift is so slow that it takes over 2,000 years for the sun to move just one constellation along the ecliptic path. Millions of years into the future, the very duration of the solstice day will undergo a subtle, invisible, and irreversible stretching in the dark. The moon acts as a silent and relentless brake on our planet's rotation, using the immense force of tidal friction to steal away our kinetic energy. As the massive volumes of the oceans are dragged across the rocky seabed by the moon's gravity, they create a microscopic drag that slowly lengthens the hours of each day. Eventually, the longest day of the year will stretch significantly further than the 24 hours we recognize and measure today. The summer solstice of the distant future will be a much slower affair, a lingering period of light in a world that takes longer to complete a single turn. This slowing of the Earth is a constant process, adding milliseconds to the year with every passing century as the tides continue their patient rhythmic work. This cosmic relationship is further strained by the startling fact that our natural satellite is slowly edging away from us into the surrounding dark. The gradual recession of the moon, moving away at a rate of roughly 4 centimeters each year, is slowly stripping away the gravitational anchor that keeps our axial tilt stable. Without the steadying hand of our massive partner in the void, the Earth's lean may eventually become erratic, unpredictable, and wild. This could lead to a future where the planet undergoes violent solstice swings, with the poles occasionally tilting directly at the sun or standing perfectly upright without any warning. Take a deep, calming breath and notice the stillness of your torso, a small pocket of peace while the celestial bodies above continue their slow-motion separation. The stable, 23-degree tilt that gives us our gentle seasons is a fleeting gift from a moon that is slowly but surely letting go. Deep within the geological record, the relentless shifting of the great continents reveals a history where the concept of the solstice was tied to entirely different landscapes. Plate tectonics has moved the massive landmasses of our world like pieces on a slow-motion chessboard across the globe over hundreds of millions of years. There was a time in the deep past when the continent of Antarctica did not sit at the frozen, dark bottom of the world, but enjoyed lush, tropical summer solstices near the equator. The fossils of giant ferns and ancient, cold-blooded reptiles found beneath the miles of modern ice tell a story of a land that once basked in a sun that never set. Take a moment to acknowledge the solid ground beneath you, a stable platform that is actually drifting through time. The solstice is an astronomical constant, but the ground beneath it is a wandering traveller that never stays in the same latitude for long, carrying its memories of tropical light into the polar night. Surprisingly, the most barren and hostile environments on our planet are part of a rhythmic cycle of greening and desertification that spans 20,000 years. The Sahara Desert is not a permanent wasteland, but a massive landscape that breathes in and out with the changing intensity of the summer solstice sun. When the planet's tilt and orbital position maximize the solar radiation hitting the northern hemisphere, the intense heat pulls monsoon rains deep into the heart of the African continent. During these fortunate periods, the shifting geometry turns the vast fields of sand into a lush green savanna filled with deep lakes and abundant wildlife. Notice the ease of your breathing as you contemplate this vast planetary respiration, a slow and rhythmic change that turns dust into life and back again. We are currently living in the dry phase of this grand solstitial cycle, waiting for the sky to tilt back toward the rain and restore the balance. If we were to rewind the clock to the era of the great dinosaurs, we would find a planet that was spinning with a much more frantic and high-speed energy. Because the moon had not yet had enough time to slow the Earth's rotation to its current speed, a single day in the Mesozoic era was significantly shorter than the one we know today. Consequently, the solstice would arrive days earlier on the calendar, as the planet completed its orbital circuit around the Sun with many more rotations per year. The ancient giants lived in a world where the sun rose and set with a different tempo, and the seasons turned with a faster, more aggressive rhythm. The solstice of that era was a more frequent event in a world that was still youthful, hot, and spinning with the momentum of its birth. This reminds us that our current experience of time and light is merely one specific variation in a long and evolving history of planetary motion that spans the eons. As we drift through these eons of planetary motion, we encounter a moment of absolute weightless suspension, like a heavy pendulum reaching the silent peak of its swing. The defining paradox of the winter solstice is that while the sun appears to stand perfectly still against the stars, the Earth is actually hurtling through the vacuum at its absolute fastest orbital speed. We perceive a pause, a frozen breath in the sky, yet our planet is racing at nearly 30 kilometers per second along its elliptical track. This incredible velocity is a consequence of Kepler's laws, as the Earth reaches its point of closest approach to the solar furnace during this exact window of time. The apparent stillness is merely a geometric trick of our perspective, a visual halt born from the most intense kinetic energy of the entire year. While the landscape below is locked in a quiet, dormant stasis, we're experiencing the most rapid transit of our lives through the deep expanse. It is a stunning contradiction that defines the very heart of the turning year, where the maximum speed of the world produces the minimum movement of the light. We are falling through the solar system with staggering momentum, yet we feel only the chill of the motionless afternoon. This hidden rush is the secret pulse of the solstice, a high-speed journey masked by the illusion of a standing sun. Surprisingly, the coldest pivot of the year holds a chronological secret that defies our common intuition about the symmetry of the seasons. We often assume that the shortest day must naturally host the earliest sunset, yet the dark curtain of evening actually begins to fall at its earliest hour, about 2 weeks before the solstice even arrives. By the time we reach the official turning point in late December, the afternoons have already begun to imperceptibly lengthen, clawing back seconds of light while the mornings continue to darken. This happens because the Earth's speed in its orbit is not constant, causing the timing of solar noon to drift away from the steady ticking of our mechanical clocks. The planet's rapid movement around the sun at this time of year means that the Earth must rotate slightly more than 360 degrees to bring the sun back to the meridian. This extra bit of turning pushes the sunrise and sunset further into the day, creating an asymmetrical start to the winter. If we were to look closer at the evening horizon in early December, we would see the true beginning of the winter's deepest shadow. The shortest day is not the day of the earliest darkness, but rather a central point in a complex tug-of-war between the planet's spin and its orbital path. It is a subtle, shifting boundary that reminds us that the rhythms of the cosmos rarely align perfectly with the grids of our invention. If we were to look closer at the frosty dawns that follow the turning point, we would discover a similar delay occurring on the other side of the day. The latest sunrise of the winter season does not coincide with the solstice itself, but instead arrives several weeks after the shortest day has already passed. While the afternoons are already showing the first faint promises of returning light, the mornings remain stubbornly trapped in the deep indigo of the polar night. This lingering darkness in the early hours can be a source of seasonal exhaustion, as the world expects a return to light that the dawn refuses to grant. The discrepancy between the shortest day and the latest sunrise is a physical manifestation of the Earth's elliptical orbit working against its axial tilt. We are essentially watching the Earth struggle to catch up with its own shadow as it races through the perihelion. This lag creates a period of heavy morning stillness that defines the start of the new year, a quiet and cold persistence of night. It serves as a reminder that the recovery of the light is a slow and lopsided process, requiring patience as the geometry of the orbit settles into a new rhythm. The solstice may be the moment of the turn, but the dawn takes its own time to follow. This cosmic structure of mismatched timings is governed by a mathematical principle known as the equation of time, a bridge between the uniform ticking of our clocks and the variable speed of the sun. Our modern world relies on mean solar time, which assumes every day is exactly 24 hours long, but the true solar time measured by the sun's position is a restless and changing thing. Notice the weight of your limbs as you rest, grounding your body in the present while the invisible math of the heavens calculates the drift of the hours. The combination of the Earth's tilt and its elliptical path creates a difference of up to 16 minutes between what the clock says and where the sun actually sits in the sky. Around the solstices, these two versions of time are moving in opposite directions at their most extreme rates, causing the drift that separates the earlier sunset from the shortest day. It is a beautiful, invisible friction between the ideal circles of our minds and the graceful, elongated paths of the physical universe. Understanding this equation is like reading the sheet music for the planet's annual performance, seeing the subtle tempo changes that keep the music alive. It proves that time is not a flat, unchanging surface, but a dynamic and fluid dimension that responds to the gravity and motion of the spheres. The solstice is the peak of this temporal complexity, a moment where the math of the universe becomes a lived experience of light and shadow. Notice the peculiar stretching of the solar day as the planet reaches these extreme points in its annual journey. Solar days, measured from one solar noon to the next, are actually longest in duration around the solstices rather than the equinoxes. This seems impossible to our logic, as we equate the shortest day with the least amount of time, but the measurement of a full rotation relative to the sun tells a different story. Because the Earth is moving at its maximum orbital velocity near the winter solstice, it covers a larger distance along its path in a single 24-hour period. To bring the sun back to the exact same point in the sky, the Earth has to spin just a little bit further on its axis to compensate for that forward movement. This adds precious seconds to the true solar day, making the time between noons significantly longer than the standard 24 hours we see on our wrists. This stretching of the day is a subtle, cumulative effect that contributes to the shifting times of our sunrises and sunsets. It is as if the planet is leaning into its turn, requiring more effort to complete its daily cycle while it races through the curve. The solstice is therefore a time of maximum duration for the sun's presence, even when that presence is at its most fleeting in the northern sky. It remains a persistent irony that the northern hemisphere experiences its freezing winter solstice, when the Earth is physically closest to the blazing sun. This point of closest approach, known as perihelion, usually occurs just a few weeks after the December solstice, placing us roughly 5 million kilometers nearer to the star than we are in the heat of July. If distance were the only factor in our climate, we would be experiencing a scorching summer during the deepest nights of December. The power of the Earth's 23.5 degree axial tilt completely overwhelms the influence of this orbital proximity, proving that the angle of the light is far more important than the distance of the source. Even though we are closer to the solar furnace, the shallow, glancing angle of the rays means the energy is spread thin across the frozen landscape. The sun's warmth is present, but it cannot pierce the atmospheric shield with enough strength to melt the frost. This irony is a profound lesson in the importance of orientation and perspective in the physical world. It shows that being close to a source of energy means very little if we're turned away from its direct influence. The winter solstice is a moment of maximum solar proximity and minimum solar reception, a beautiful contradiction written in the ice and the light. Deep within the vast distance between our world and its star, the light itself must perform a long-distance sprint before it can reach our eyes. Because light takes approximately 8 minutes and 20 seconds to travel from the sun to the Earth, the astronomical event of the solstice actually occurs millions of miles away before we can visually confirm it. Take a slow, deep breath and feel the steady rhythm of your heart, recognizing that you are always looking at the sun as it existed in the recent past. When we observe the sun standing still at its northern or southern limit, we're witnessing a ghost of a moment that has already concluded in the vacuum of space. By the time the photons carry the image of the solstice to our telescopes and stone circles, the Earth has already moved thousands of miles further along its track, we are perpetually out of sync with the celestial clock, living in a delayed reality that is dictated by the universal speed limit of light. This delay means that the solstice is not just a point in time, but a message sent from the past that finally arrives to illuminate our present. It highlights the staggering scale of our solar system, where even the fastest thing in existence needs time to cross the gap. The solstice we celebrate is a beautiful 8-minute echo of a planetary alignment that has already passed. Surprisingly, the very fabric of time undergoes a microscopic relativistic change as we reach the peak of the winter season. Gravitational time dilation dictates that time moves infinitesimally slower for Earth during the winter solstice, because we are deeper within the Sun's gravity well at perihelion. According to the laws of general relativity, the closer an object is to a massive body like the Sun, the more the surrounding space-time is warped and the slower time appears to flow. Because we are physically closer to the Sun's immense mass in January than we are in June, the ticking of our atomic clocks is slightly more sluggish compared to a clock floating in deep space. This difference is so small that it can only be measured by the most precise scientific instruments, yet it is a fundamental truth of our physical reality. We are living in a slightly slower time stream during the winter, literally experiencing a different tempo of existence. This adds a profound layer to the concept of the Sun standing still, as the world itself is moving through a localized distortion of time. The winter solstice is a moment where the gravity of our star pulls most strongly on our planet, anchoring us more firmly in the cosmic fabric. It is a quiet, invisible stretching of the seconds, a relativistic breath taken by the Earth as it swings through the deep. If we were to look closer at the invisible heart of our solar system, we would find that the Sun itself is not the true unmoving centre. The true centre of the solar system, known as the barycenter, is the common centre of mass around which all the planets and the Sun itself rotate. Because the massive gravity of Jupiter and Saturn pulls on the Sun, the barycenter constantly wobbles, often moving entirely outside the Sun's visible surface. This constant shifting of the solar system's balance point means that the exact microsecond of the solstice changes from year to year, independent of the Earth's own orbital variations. The solstice is not a fixed geometric point relative to the Sun's centre, but a moving target dictated by the collective weight of the entire planetary family. The Sun is essentially performing a slow, looping dance with its children, and the solstice is our way of marking the rhythm of that dance. This realization shifts our perspective from a single planet focus to a holistic view of a connected spinning system. The solstice is a collaborative event, a result of every massive body in our neighbourhood pulling on the fabric of space. It is a reminder that we are part of a complex and beautiful machine that has no single static anchor, but moves in a grand collective harmony. Ultimately, the sweeping celestial path of the solstice sun is merely a magnificent illusion, created by the silent, relentless spinning of the rock beneath our feet. We watch the star climb high or sink low. We track its north and south migrations, but the star itself has barely moved relative to the centre of the galaxy. It is our own planet that provides the drama, the movement and the change, tilting its face toward and away from the light in an endless rhythmic bow. Notice the profound stillness of the ground beneath you, a solid and comforting platform that masks the reality of a world in constant high-speed rotation. Every shadow that stretches across the snow, every long twilight, and every standing sun is a direct consequence of the Earth's own posture in the void. We are the architects of the solstice, creating the seasons through our own tilt and our own journey. The solstice is the moment we catch the planet in its act of turning, a fleeting glimpse of the geometry that governs our lives. It is a celebration of our movement through the stars, a way of acknowledging that we are part of a much larger spinning story. By understanding the paradox of the turning point, we finally see the world as it truly is, a beautiful, tilted traveller moving forever through the light. Deep within the realization of our journey, we find that the solstice is not merely a distant event happening in the sky above, but the silent tilting signature of our own fragile planet. This annual pause is the physical proof of our home world leaning into the vastness of the dark, a gesture of survival and grace in the void. It is the final synthesis of every shadow and every beam of light, reminding us that we are always exactly where we need to be. This quiet room becomes the vessel for your final release as the journey through the heavens concludes and the weight of the stars is set aside. Notice the soles of your feet and the tips of your toes, letting them feel heavy and warm against the softness of the sheets. Surprisingly, the body recognizes this moment as the ultimate nadir, a point where the outward energy of the day finally stands still. If we were to look closer at your ankles and calves, we would see the tension draining away like light at the end of a long evening. The muscles of your thighs and hips settle into a deep gravitational embrace with the comfort of the bed. This is your own orbital pause, a transition from the frantic spin of the day to the slow, heavy stasis of the night. Deep within your center, the breath begins to lengthen, mimicking the slow expansion of the atmosphere under a fading sun. Feel your stomach and the small of your back softening, surrendering their weight to the supportive layers beneath you. Your chest rises and falls with a rhythmic grace that mirrors the tilting heartbeat of the world. This cosmic structure of relaxation continues up through your fingertips and into the warmth of your palms. Every finger curls naturally into a state of total and unthinking ease, releasing the grip of the world. The heavy weight of your forearms and elbows anchors you to the present, a physical signature of peace in the dark. The muscles in your neck and the base of your skull finally release their persistent, silent hold on the day. This quiet room provides a sanctuary where the heavy weight of the mind can be gently set aside without effort. Notice how the blankets wrap around you, providing a tactile shield of warmth and absolute security. If we were to listen to the rhythm of this place, we would find it filled with the soft, repetitive music of your own breath. Every inhale brings a sense of cool, clean peace, while every exhale releases a cloud of heavy, restorative comfort. The pillow is a soft and patient cloud, cradling your head in a state of weightless suspension. Surprisingly, the body finds its greatest strength in this total and unyielding surrender to the night. Your eyes grow heavy behind their lids, the muscles surrounding them smoothing out into a peaceful and dreamless blur. The skin across your forehead is cool and undisturbed, reflecting the deep stillness that has settled over the furniture and the floor. The outside is far away, and the only reality that remains is the gentle, steady beat of your heart and the warmth of the air. You're sinking, falling softly into a well of deep and restorative quiet. And now, 101 wonders are resting with you. Sleep now. Good night.